Hi everyone, Nicolette here. You have joined me on Gabnick Excelsior Nursing Tutoring Center's YouTube. So if you are watching this video, it's because you are interested in some science, medical, something related to the health field, and you have to take certain science classes. Well, today we're going to be reviewing chemistry. So I too am part of the health field. I am a nurse practitioner, but it is my goal and always have been my goal to become a medical doctor. So I'm going to use my studying time to be an instrument of help for you. So I have to take the MCATs. I am not a young person, even though I look young. I'm 36 years old and I've already gone through my undergrad and even graduate school with my nurse practitioner degree. But I still want to pursue my dream of becoming a medical doctor. I want to be a cardiologist. So I decided that I want to go back to school, take my MCATs and go back to school. But what I noticed is that I have forgotten so much of the preliminary information that I needed, like chemistry, organic chemistry, biology. So I decided that that I'm going to go back and I want to take you on this journey with me. And if you are in school now and you're interested in getting into medical school, or nursing school or some scientific something, then this is definitely the channel for you. I want to share with you that I have written a book entitled How to Beat a Rigged School System. In this book, you will also find studying tips of how to study. I'm going to be using these studying tools as I get to my medical degree, okay? So this is the book to buy, okay? I wrote it and I'm gonna be using the same information to acquire my MD degree that I used to get my RN and my nurse practitioner. So let's just jump right into it. Today we're going to be doing chemistry. So we're gonna go way back, right? We're going to do Barens review. I will be reading it for you so that you might not have to read it yourself. And as I go through it, if I find something that is interesting that I want to mention, I will stop, pause, and do that. But mostly this is going to be a reading, okay? Because I find that we are sometimes pressed for time and we don't really want to sit down and read. And if we had an auditory source of the information, then it would be better for us, right? So this is the chemistry. Let's review chemistry, the physical setting, Barens review. So this is a high school book, guys. This is for students who want to take the Regents in high school. I had to go all the way back because, like I said, I forgot a lot. And actually, even when I was in school, I didn't understand chemistry as well. So I had to review it again anyway because I was studying for exams. I didn't really understand and grasp the information, and now I'm going to need it to take this major test, okay? So I'm going to start from the very beginning. I will go slow. I'm going to time it so that it's 15 minutes long each time. And wherever I leave off, I will start back up again. You will actually hear the timer. So in my book, I teach how to be able to review the information and how do you get through so many pages and still allow your mind to think that you have time. And that is the way to do that is to actually time yourself and then see how many pages you've read in that amount of time, and then divide how many pages you have to read in all. And that'll tell you how long it will take you to read that book. So I am reading the book in 15-minute intervals. It's also good for this channel because it's just, it's not that long. And so you can have 15 minutes of study time or reading time or listening time, okay? So we're gonna start from the very first page. Chapter 1. So you can buy this book on Amazon. That's where I got it from. So Introduction to Chemistry. This chapter introduces some of the basic concepts in chemistry that serve as a foundation for the chapter that follows. In particular, measurement and problem solving are studied. Key objectives. In the conclusion of this chapter, you will be able to define the terms chemistry, matter, pure substance, and mixture. Distinguish among elements, compounds, and mixtures. Distinguish between physical and chemical properties. Indicate how mixtures are separated. Distinguish between physical and chemical changes. List the various forms of energy. List the common metric units used in chemistry. Name the most commonly used metric prefixes and their numerical equivalents. Express numbers in scientific notation. Perform simple operations in numbers expressed in scientific notation. Define the term volume and density as they apply to chemistry. Describe how measurement readings are taken and estimated. Define and apply the term accuracy, precision, and significant digits, figures. Apply the rules for adding, subtracting, and multiplying, dividing, and measurements, or multiplying measurements. Define the term percent error and calculate the percent error of a measurement. Understand the factor label method, FLM, and use it to solve problems. Use equations and graphs to solve problems. So reminder, if you have not already done so, read preface to the student at this time. We're not going to go do that. We're going to continue section 1, basic regent level material. New York State Regents, Concepts and Skills. By the time you have finished section 1, you should have mastered the concepts and skills listed below. The Regents Chemistry examination will test your knowledge of these items and your ability to apply them. Concepts are the basic ideas that form the body of the Regents Chemistry course, what you need to know. Skills are the activities that demonstrate your mastery of these concepts, how you show that you know them. Following each concept or skill is a page reference given in parentheses to this chapter. So 1.1, the concept is, matter is classified as a pure substance or a mixture of substances, page 4. 1.2, concept, the structure and arrangement of particles determine the phase of a substance. The 3 phases of matter, solids, liquids, and gases, have different properties. Oh, you guys, I didn't even turn on my timer. Wow. As a simple particle model, diagram to differentiate among, use a simple particle model / diagram to differentiate among the properties of a solid, a liquid, and a gas. And that's found in page 4 and 5. 1.3 concept, a pure substance, element, or compound has a constant composition and constant properties throughout a given sample and from sample to sample, page 4 to 5, skill. Use a simple particle model / diagram to differentiate among elements, compounds, and mixtures, page 5 through 6. 1.4 concept, elements cannot be broken down by chemical change, page 4 through 5. 1.5 concept, mixtures are composed of 2 or more different substances that can be separated by physical means. When different substances are mixed together, a homogeneous or heterogeneous mixture is formed. That's page 5 through 6. 1.6 concept, the proportions of components in a mixture can be varied. Each component in a mixture retains its original properties. That's page 5. 1.7, the concept is, a physical change results in the rearrangement of existing particles in a substance. A chemical change results in the formation of different substances with changed properties. That's page 5. Concept 1.8. Energy can exist in different forms, such as chemical, electrical, electromagnetic, thermal, mechanical, and nuclear. That's found in page 12 through 13. Concept 1.9. Algebraic and geometric representations can be used to describe and compare data. Skills. Organize, graph, and analyze scientific data. Page 27 through 31. Recognize and convert various scales of measurement. Page 23 through 25. Concept 1.10. Algebraic and geometric representations can be used to recognize patterns and relationships in mathematics. Skills. Identify direct and inverse relationships. Pages 28 through 29. Use data trends, such as those shown in graphs, to predict information. Pages 28 through 29, 30 through 31. Concept 1.11. Algebraic and geometric concepts can be used to solve problems. Skills. State what assumptions are made when a mathematical equation is used. Pages 24 through 27. Evaluate whether an answer to a numerical number is reasonable. Pages 25 through 27. Concept 1.12. Differences in properties such as density, particle size, molecular polarity, boiling point and freezing point, and solubility permit physical separation of the components of a mixture. So differences in properties such as density, particle size, molecular polarity, boiling point and freezing point, and solubility permits physical separation of the components of a mixture. Found on page 6 through 12. Skills. Describe the processes and uses of filtration, distillation, and chromatography in the separation of a mixture. So before this reading, I had not remembered what chromatography is, but I find that it does explain it later on. So as you read, if I'm saying something that using a word or introducing a concept that you do not understand, you don't know if I'm going to be able to explain it later or if there's more information on it later. So I would recommend that you pause the video and go look up that word or concept so that you can better understand what is going to be read later on. So if chromatography was one of those words for you as it was for me, then I would pause the video and go ahead and look that up. So describe the process and use of filtration, distillation, and chromatography in the separation of a mixture. That was found in page 6 through 12. Okay, and now we begin. 1.1 Chemistry is. Chemistry is the science that focuses on the structure, composition, and properties of matter. In our study, we will also learn about the changes that matter undergoes and the energy that accompanies these changes. 1.2 Matter and energy. Our universe is composed of matter and energy. Matter is anything that has mass and volume, that is, anything that has density, a concept we will develop in section 1.6. So they've already kind of given you the formula for density, right? We're going to see that density equal mass over volume. So our universe is composed of matter and energy. Matter is anything that has mass and volume, that is, anything that has density, a concept we will discover or develop in section 1.6. Matter commonly exists in 3 phases: solid, liquid, and gas. Generally, solids are composed of particles that are tightly packed and have a regular arrangement. These particles present in gases have no regular arrangement and no appreciable packing. In liquids, the arrangement and packing of the particles are somewhat between those in solids and gases. As a consequence, a solid has a definite shape and volume. A liquid has a definite volume but takes the shape of its container. A gas has neither a definite shape nor a definite volume. Its shape and volume are those of its container. We can use particle diagrams to visualize solids, liquids, and gases, and to distinguish among them as shown below. So I'm just going to show you what the particle diagram look like. So that right there is the gas, if you can't see it. This right here is the liquid, and that right there is the solid. So that is the diagram. Substances. For convenience, we divide matter into two classes: pure substances and mixtures. A pure substance is any variety of matter that is homogeneous, uniform, and has a fixed composition by mass. So it's homogeneous and is fixed. That is a pure substance. Elements are classified as substances because they contain atoms of a single type and cannot be decomposed further. Although compounds contain more than one type of element, they are also classified as substances because their compositions are fixed. For example, in every sample of water, the ratio by mass of oxygen to hydrogen is 8:1. Because this ratio cannot be changed, we usually say that the element in a compound are chemically combined. The accompanying particle diagrams represent two different elements and a compound. So here's an example here. So right here, this represents the element. The second one, this also represents an element. And this here, this represents a compound. Okay. So the first thing here was when it said, I hadn't understand like elements or substances and compounds or substances, but they have, the element is, I understand, okay, it's pure. So we have the pure, and so it says two pure substance and mixtures, right? So elements are still substances because there's only one type in it and they cannot be decomposed. Compounds are substances because they are fixed. So even though they have multiple elements in there, they cannot be shift or change. And if there's any change, then you're changing the whole compound. It's no longer that compound, okay? So when I looked at this, I'm like, why is this an element, right? Well, this, as you can see, they're the same color. So they are of the same, because some elements come in twos, right? So O2, H2, right? That's how they exist. They don't exist singly, okay? So that's what I learned about that. If you were wondering, like I was, why is there two things? I thought elements are just one thing, right? Okay, moving on. Every substance has a unique set of properties that allow it to be distinguished from other substances. These properties can be grouped into two categories: physical and chemical. Physical properties can be measured without changing the identity and composition of a substance and include color, odor, density, melting point, and boiling point. For example, when the melting point of a substance is measured, its phase changes from liquid to solid, or from solid to liquid. The appearance of the substance changes, but not its composition. Changes that accompany the measurement of a physical property, or changes that accompany the measurement of physical properties, are called physical changes. For example, all phase changes are physical changes. So the example you can use here is water, right? So water, ice is still, the composition of water is still there, right? And when it's melted, and then when it's steamed, right, vapor, water, it's water vapor, the ice will melt into water. So it's still the same, even though the shape or physically it looks different. So this is what they're talking about here. Chemical properties are properties that lead to changes in the identity of a composition of a substance. For example, combustibility is a chemical property. When hydrogen gas is burned in air, the hydrogen combines with the oxygen in the air and changes into water. A substance whose composition is entirely different from that of hydrogen. Changes that accompany the measurement of chemical properties are called chemical changes. They are also called chemical reactions. For example, when a battery provides electrical energy, the change that occurs inside it are chemical changes because entirely new substances are produced. So in this example, using the same concept of water, water is H2O, so it's one hydrogen and two oxygens. So by themselves, hydrogen, you cannot drink it. It's not water. By itself, H2 or even H singly, which doesn't exist by itself, is not water. You cannot drink it. Actually, it'll kill you, right? Will it kill you? Hydrogen will kill you. Well, I don't remember which one will kill you, but I know separately, they're not water. So physically, when they're separated, they are elements, right? But together, when you're combining them, you can only combine them chemically, right? And once they are combined chemically, now not only do they change physically, they look different, but they also are different. So when it's changed chemically, now it's a whole different substance. So hydrogen by itself is a gas and oxygen by itself is a gas. But then once you combine them together, they become a liquid, water that you can drink and that is safe. Okay. Moving on, mixtures. The mixture is composed of two or more distinct substances, but the composition of mixtures may be varied. A solution of sugar and water is a mixture because the ratio of sugar to water can be changed. A solution is an example of a homogeneous mixture because each component, sugar and water in this case, is uniformly dispersed throughout the solution. An ice cream soda, on the other hand, is not homogeneous because each component, ice cream, syrup, soda, whipped cream, is not uniformly. I'm going to repeat it because I'm not done with this section. So that was 15 minutes already. And so just keeping this momentum here, at least to get to the end here. Homogeneous mixtures so let's just go back. It says, a solution is an example of a homogeneous mixture because each component, sugar and water in this case, is uniformly dispersed throughout the solution. An ice cream soda, on the other hand, is not homogeneous because each component, ice cream, syrup, soda, whipped cream, is not uniformly dispersed. This is an example of a heterogeneous mixture. The accompanying particle diagram represents a heterogeneous mixture. So this is a heterogeneous mixture. So you see that you have the little white ones, that's different. The little gray ones is different. The black ones are different. And then the mixture together, when they connect together, the gray and the black, is something different as well. So you have all these different particles, right? That makes a heterogeneous mixture because they're in different sections of the container, you'll find different looking particles, right? So we're going to end here. Thank you for listening. I will continue on with another 15 minutes, and I hope that you join me for the next section of our chemistry. We're still on chapter 1. I'll see you then. Bye.